Did you see my message about the feedback? Did you not know
No.
how to check the feedback in there?
Exactly, that's why I texted you.
So you didn't know how to click that view feedback and that it opens up the assignment?
I just saw that she had posted view assignments or
View
something, and I went there, I couldn't find anything, I didn't know how to do it, but I think I figured out why you took points up. It was because everything everything moved over to the, like, all my boxes and everything had moved over. Is that what you were saying?
No, I don't think so. So I want to, because go into grades, because I want to show you.
I did it again today, and I came up with the exact same numbers, so.
Oh, what is that? No, that's different.
What are you talking about? Which one are you talking about? The assignment we did in class?
Yeah, with the it was your descriptions where you had a problem.
Oh.
Yeah, here. Let me. I want to
so-
make, because I'm thinking. So click on grades.
Yeah, that's what I did. I saw that there was something on the grades, and then I looked at it and I couldn't figure out what was wrong, so I went through and did it again, and my numbers were all the same.
No, I think you had that right.
I thought it was just because I had everything shipped.
No, I don't think so. So do a Control F. And then type in 11.10. Okay, so here it is, right? So click on this. Did you see my follow-up email? Okay, so see this?
Okay, yeah.
Click
So
that.
I saw see feedback inside of assignment.
So that's this, view feedback.
Okay, I was just clicking on this. I don't know that
Okay.
I saw that.
So that's what that, when you see that, that's what that means. Click
Okay.
on the view feedback. Scroll down. So whenever you see that, a message that says see view feedback, that's what that means.
Make this full screen there. So, oh, there we go. Okay.
Yeah, and then I think you can even still make it bigger.
Oh, yeah.
Yeah, so I think the only thing is you're missing the VLAN 1, right? Source device, switch 1, source interface, VLAN 1.
Oh, okay. So I need to add the VLAN.
Yeah.
Okay. Right.
But it occurred to me that you might not realize how to go into that view feedback, and I don't think
I didn't. That's why I sent you the note.
Yeah.
I was looking and looking. I'm like, what is wrong with this thing? Because
Yeah.
I did my numbers. I did them again today, and the best I could come up with when I did this was.
Yeah, those, you had all the addresses right. Let's see, hit escape. Okay, there you go.
There we go. Yeah, I had. Where is my assignment? If I click on it, does it pull up my assignment? If I click on this other one?
I don't think so. Oh, there it is.
This,
Yeah,
right?
yeah, that's what
See,
you
like,
turned in.
When I did this.
That just shows you what you turned in.
And I couldn't figure out what you had done. I didn't know if you had.
Yeah,
I didn't
always,
know.
whenever you
Okay.
see that, that means we've put stuff in on there. Yeah. You have to download it.
I thought I already opened it.
Here, try here. Is it in there, Daniel?
CNT, that's 11 point. Yeah, that's
Yeah,
it.
that's it. So then you can open that.
Yeah, see, this is what I thought I had done wrong. And you have to, if you could help me with this, it's really been frustrating. I see how you can copy and paste all of my stuff. Oh, this isn't it. It fixed it. Okay, never mind. When I looked at it earlier today, one copy that I saved, all of these boxes were shifted over because remember how you told me to put these in?
Oh, yeah.
So I don't know why it's like this on my laptop. It's not like this.
Oh.
But that's why I thought maybe it was wrong, and so I was going to ask you, like, how do I fix it? But look, it looks like it's fine in here.
Yeah.
Okay, whatever.
It's a difference probably between your screen size.
Maybe.
Yeah.
That might be it. I don't know. That was just really weird. I racked my head earlier today trying to figure that out. Okay, I'll fix that then.
Okay.
And I got to come in to do that now.
Yeah. If you have flashcards, can you raise your hand so I can see who has flashcards today? Flashcards? Okay. Okay. right. Okay, so I think, let's see, there's quite a few people who don't have flashcards, so let's do something a little different. Those of you that have them, I want you to pick 2 good flashcards with good questions or something that I could turn into a question, okay? And make sure your name's on both of them so that I can give them back. And I'll ask the questions from the front of the room. And we'll talk about them that way. Good one. Good ones. You can't answer your own questions. Let's see. Yep, that's what I'm going to do. This is good. I've already got that one. Give me another one. Let me see. Good one. Good one. Okay. Joy, did you have 2 good ones? Let's see. I like that. No, that's a good one because it still applies. I already have that one as a question that someone turned in. So you got to find another one. Okay. Let's see. Thank you. Okay, yes, I'll take this one. Let me see what you're, okay. I'm going to take this one, however, I'm going to word it a little differently because I'm just going to word it a little differently because I'm not sure you understand that the answers are different. That uses this. You have the, yes, good one. That is a good one. Lou? No. These 2, let's see. Do I know the answer to that? Oh, okay, I do. I'm like, what is that? But now I know. Good questions. Good questions. Is your name on them? Yes. Okay. Did you give me yours, Matt? Yes. And okay. Everybody that made cards gave me 2 cards, right? Or am I still waiting for one more from you, Ozzy? Okay, let me. okay, I can go with that too. Put your name on that. You don't have your name? Okay, put your name on that too. I have one similar to this, so we'll cover that topic. Yeah, okay. All right. Okay, so let's see here. IPv6, pretty interesting, right? Okay, so I'm going to use your questions and some of my questions for us to get an overview of everything that we need to do for IPv6, okay? And actually, before we start this, I want to remind everybody that May 5th is the last day to turn in late assignments. For example, if you have something that we did 3 weeks ago and you finished it, or you want to finish it and turn it in, you can do that up until May 5th, okay? And yeah, so, to take advantage of that time if there's some things, especially sometimes I find people did things and they just forgot to turn them in. You want to do that. Also, if you've missed any in-class activities, you can submit the in-class activity makeup assignment and request to do in-class activities. Okay, but that one you have to send a request and ask, and then I'll set up a time and you can make up those. The only ones I don't let you do for the most part are Kahoots, because we have to run those dynamically. A lot of times in the last week of school, I'll do a Kahoot makeup night. So and just do a game night, and we do prizes, I order pizza, we just kind of do a whole fun thing of it. So I might do that, and that would be finals week. We're not going to come here to do a final in finals week. You will actually take the NetAcad final at home, and we are doing the skills project in week 14, the final skills project in week 14. This is week 12, so we'll be doing the final skills project in week 14, and we do that in class. We'll be building a lab, okay? All right, so those makeup assignments. IPv6. Okay, so one question that wasn't in here that I would like to ask, and this is related to IP protocol in general, right? So we're dealing with the IP protocol, and under the IP protocol falls IPv4 and IPv6. What are 3 characteristics of IP? Lou? Nope, the 3 characteristics of IP. Well, I'm talking about the IP protocol in general as it relates to IPv4 and IPv6. You would have read this in module 8. What is it? Best effort. Okay, remember, so these characteristics apply whether it's IPv4 or IPv6. So best effort, connectionless, good job, and media independent. It's important to remember it doesn't matter if we're dealing with IPv4 or IPv6, these characteristics still apply. Okay, they still apply. Okay, one of our first questions is about the IPv6 address itself. So let's talk about all of the things that we know about an IPv6 address. Okay, first of all, how many bits are in the IPv6 address? 128 bits. Okay. How many hex tets do we have in an IPv6 address? 8 hex tets. Okay. And how many bits are in each hextet? Right? There's 16 bits per hextet. Okay? What is a nibble? What? 4 bits. Okay, so a nibble is 4 bits. Okay, where 4 bits equals 4 bits equals 4 bits. Okay, 4 bits is a nibble. A nibble. Okay. Let's just kind of compare this to the way that we first learned about IPv4. Okay, so we can do also just a little review right now. And IPv4 is made up of 4 what? Octets. How many bits are in an octet? 8 bits in an octet. 8 bits in an octet, right? Now, if there's 8 bits in an octet, what else is that considered? 8 bits is also considered a byte. 8 bits is a byte. That's where we get 4 bits is a nibble. Taking a little nibble, okay? That's where that comes from. And there's how many bits in an IPv4 address? 32, but in IPv6, 128. All right, so again, we're just kind of learning the new terminology that applies to IPv6, but there are some similarities, right? We initially learned about octets, we learned about bits. We're doing the same thing here. Okay, how many parts make up an IPv6 address? You can't answer that question because it's your question. Okay? There's 3 parts to an IPv6 address. We all agree with that? Okay. What are the 3 parts? Okay. So I'm going to call it global routing prefix. Global routing prefix. Global prefix is good too. Routing is a little more specific. Subnet ID. And then what's the last one, Ozzy? Subnet ID and the interface ID. Okay. I want to break this down a little bit too. And I'll draw a picture of it. The global routing prefix and the subnet ID. Hi, Orgil. That's the equivalent to the network, okay? That's the equivalent to the network, right? Again, we have some similarities with IPv4, but they're just a little bit different. Like in IPv4, we have a network portion of our IP address, and we have a host portion, okay? Well, the interface ID, that's the same thing as the host portion. So this is the network portion, and this is the host portion, okay? Our address will look something like this. 2001, a bad CAD, 1111, and then I'm just going to like do some random numbers. Okay, so it's just a random smashing of numbers. How many hextets make up the global routing prefix? Okay, so these first 3 are the global routing prefix, okay? How many bits is that? 48, right? There's 48 bits here. Each of these are 4 bits. It's a nibble. So we have 4, 8, 12, 16. And then we have 4, 8, 12, 16, 4, 8, 12, 16, so that's 48. Okay. Joey, how many in the subnet ID? How many bits in the subnet ID? 16. So this is the subnet ID, and there's 16 bits there. And everybody, what did I say this part makes up? What do we consider this? The network portion. These are all the network portion. And over here, this is the what? The hosts. And if we want to call it by its proper name, it's the interface ID, right? Or the unique ID, the unique interface ID. That's just like our host in IPv4, except it's host for IPv6, okay? And if we think about IPv4, there's things that we can apply to our IPv6 address, okay? So in IPv4, what is the definition of the network address as it relates to the host bits? All of the host bits are what for a network address? What? Not for the network. All of the host bits are what for a network address? They're off. The same is true with an IPv6 address. All of the host bits are off. So I could look at this, and this is the network. And so if I turned all those off, that would be the network address. It's just, so I just want you to see that there's some similarities, okay? Now, if I needed to know the first usable address of an IPv6 address, what would I do with the host bits? All the host bits would be off except the last one. Yes. Right? All the host bits would be off except the last one. That's the same. It doesn't matter if we're talking about IPv4 or IPv6. Now here's something that's different. Okay, here's something that's different. Does IPv6 have broadcast addresses? There are no broadcast addresses. Okay? And so how would I figure out the last usable address of an IPv6? This is the only thing that's different. What would I do with the host bits if there's no broadcast? All the host bits would be on. They would all be on. There's no broadcast, so I'm not trying to save that address. So the broadcast would look like this. Or the last usable, there is no broadcast. It just means all of the host bits are on. They're all on. Okay? Got it? And we'll review that. Okay. Now, there's 3 different types of IPv6 addresses. You can't answer this either. Well, hold on a second. Gabby's answering all of them. So, Gabby, you can't answer this either. Okay. But she did give us unicast. So there's 3 types. Yeah, multicast and anycast. Unicast is a what? 1-to-1, right? That's just a 1-to-1. Multicast is multiple, so what? So it's what to what? What to multiple? 1 to many, 1 to multiple. Yeah, so this would be 1 to many, right? This would be 1 to many. Okay. Now, an anycast is not actually something we need to understand at a deep level, but we just have to know that they exist. And I'm going to generically kind of tell you what an anycast is, just because I think it makes more sense that way. An anycast would be typically used for something like servers, okay? So let's say that this is me on my computer, and there are multiple servers on this network, DHCP servers. Let's be more specific. Let's call them DHCP servers. It just makes it a little bit easier. For an anycast, what we would do is these would get an IPv6 address that matches. They'd all be the same. So this would be, they'd all have the same IPv6 address, but they'd also have their own unique IPv6 address. Okay, so one of the things about IPv6 is a device can have a lot of different IPv6 addresses. That's one of the things that makes IPv6 more efficient. Okay? And what would happen is when my host gets turned on and it wanted a DHCP, it wanted to contact the DHCP server, it would send out a message. And it would go to the DHCP server address. And whichever DHCP service answers it first is the one that would respond. Okay, so all it does is it makes it so that they can all have the same address, but whoever receives it first does the response. Okay, so that's all we need to know about an anycast address. This guy wants to have an address, so the message goes out to that same address, and let's say this one gets it first, it will respond first, and these will just drop it. Okay, so anycast just allows us to assign multiple devices the same IPv6 address. And it's for efficiency. It's to increase efficiency. Like, that's a very high-level generic view of an anycast address, okay? All right, questions about any of that? Yes? You have questions? Oh, Lou? You will just need to know that there are 3 types of addresses. The ones that you need to understand are unicast and multicast, and then you need to understand that there is also an anycast address. And that's the extent of it. Okay? Okay, let's see. If we're going to do IPv6 in our network, and we're going to be configuring things, what do we have to do to the router? What's the configuration that we have to do to the router to let it know? Yes, IPv6 unicast routing. Okay, and that's the command. What mode do we enter that in? Global mode. Okay. I do it right in the beginning. I just like to get it. I do it in the beginning when I'm doing all the other commands like no IP domain lookup, the host name. I just get all that in there. Same goes on the switches. On the switches, you have to do the SDM prefer command. If I'm going to do IPv6, I just get that done right off the top. I do that, do a copy, run, start, and a reload so that they're done, and then I don't have to think about it again. Yep. Okay, so I did this. So I did this. All right, there's a couple of different. Okay, so let's go back over here to unicast. We said that there's unicast and multicast. How many different unicast addresses are there? 6. Okay, there's 6. All right. Ozzy, can you give me one? Without looking it up? Do you have it in your notes? Joey. One of the 6 types of unicast addresses. Yes, okay, so we're going to do a global unicast. Okay. Now, in the IPv4 world, the global unicast is similar to what in IPv4? Public. This is similar to a public address in the IPv4 world. Okay. Joy, do you have one? Marcus? Daniel? Yeah, a link local. Okay. Now, I really, really, really want you all to learn and understand about the link local address. Okay. Now, what does a link local address start with? What would it look like? It's going to look like an FE80. And that could actually be anything between an FE80 and an FEBF. Okay, that can be anything between an FE80 and an FEBF. Okay. Now, what is the link local address for? Internal, meaning what?
Can't access the internet.
It can't access it.
Every device has one if it's IPv6 enabled.
Yes. Okay. Let's add all that. Okay. So the fact that it's a local, link local, that means that it's local to the network it's on, right? So it's local only. You said it can't access the internet, right? It can't access internet. Now, the other thing you said that's so important, and I want everyone to make sure you learn this, is about the devices. So say that again.
Every end device that's IPv6 enabled will get one.
Yeah, every device that's IPv6 enabled. So not just the end devices, the routers, the switches, all of them. Okay, so let's see. Every IPv6 enabled device has to have one. This is another way that IPv6 has increased its efficiency. It's made it so that every device gets one so that they can all communicate, at least within their own local network. Now, in the IPv4 world, what does that seem like? What does that sound like? A PIPA. This is like in the IPv4 world, we have a PIPA. And what else? What's that? Yeah, and private. And private. And what does an APIPA address start with? Anybody, what does an APIPA address start with? Yes. The APIPA starts with 169. And what would a private address start with? So we would have a 172. What else? There's 3 private networks. What is it? 10, yeah. A 10 and a 192. Okay? You have to always be reviewing this stuff, right? Can't forget it just because we've gone into a different module. Okay, pull up a command prompt and do ipconfig. ipconfig. Pull up a command prompt and do an ipconfig. Does everybody see their link local address, the FE80? Okay. So every network device, every host device will get their own IPv6 link local address if IPv6 has been enabled, which in this case it has. Okay. Someone try to ping my link local. Matt, try to ping my link local. This one right here, this first one. Oh, I'm going to call it out. Okay, ping space, and then FE80 colon 14A8 colon D4 F2 colon 1E F9 colon 713E.
Is that it?
That should be it.
It's banging.
Good. Okay. So our devices can all communicate on the IPv6 network through our FE80s. Okay? Through our FE80s, like the APIPAs. Okay, now one difference is APIPA. When do we get an APIPA address?
There's no DHCP.
When there's no DHCP.
Set to automatic.
Exactly. And for the FE80s, we'll get it whether there's a DHCP or no DHCP. It's going to get it. Okay, so we have two of them. Orgil, do you have one of the unicast addresses for IPv6? Yes, a loopback. A loopback. And what is the loopback address for IPv6? That's for IPv4, ::1. So go ahead and ping that too. ::1, ping, ::1. All right, everybody get that? Lou, can you give me another unicast address? Yes. So I'm going to put embedded right here. And what is an embedded IPv6 address? Or what's it used for? Embedded IPv6 address. Yes.
Is it like a static?
Not necessarily. It probably usually would be static, but it has a very specific purpose. An embedded IPv6 address has a very specific purpose. Gabby? Yes. Yeah. Okay, so this gets a little complicated, all right? Normally, what we've done is when we were running an IPv4 and IPv6, we would do a dual stack network. We would configure IPv4 and we would configure IPv6 and we would run them concurrently. Well, there's another way that you can do it using embedded addressing, where you would actually take an IPv6 address and encapsulate it. You would embed it inside of the header of your IPv4 packet, and then that packet kind of carries it like a bus, right, or a train, so that it can get through the IPv4 network. And you can do that in reverse as well. You can embed, so if a company's running an IPv6 network, they can embed an IPv4 address inside of an IPv6 header. So it's a way to allow IPv4 and IPv6 to coexist, okay? And I think that there's NAT64 might be a part of that, And that, again, allows coexistence. Okay, so we're missing still two, one of them being pretty important and one of them being weird.
Is the embedded part of like the tunneling thing?
Yes.
Okay.
Yeah, it's tunneling, exactly. Okay, what are the other two? A unique local. Okay. And pay attention to the words. Unique local. The fact that it has local in it tells us what? It's like a private address. It stays on the LAN. Exactly right. It stays on the LAN. It is not internet routable. Okay? It's not internet routable. Let me give you an example of how we could use a unique local address. Okay, so let's say that this was one local area network right here, and next door was another totally different local area network. The only way we'd be able to talk to them is with a router, okay? However, I could use a unique local address, and I can make us part of the same unique local network, so that even though we're separated, we can all still communicate, okay? But it's only can be used on LANs. It can only be used on LAN. So it's a way to let similar or related networks communicate. So let's say that we were human resources, and over there they were, what would be related to human resources? Sales? Is there something even, how about like hiring, right? Human resources, maybe there's like a hiring department, right? They're related but different, but we want them to be able to communicate and share information. We could be on the same unique local department, even though we're on totally different actual networks. Yes?
Are those two networks still separated by 2 routers?
One router. So this is how it might look. Router, right? So here's human resources. And again, this is very simplified. There's a couple different ways that unique locals can work. Okay, so human resources and what we called it hiring, right? Where they actually maybe process people. Okay, different networks, right? Different networks. And maybe this, again, is a 2001 something something AAA. That's the network. And over here it's 2001 blah 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 BBB. They're actually different networks, but we can assign them unique local addresses from the same network so that they can communicate because they're related. Okay?
2 networks, or can you do unfigured, or does that,
Say that again.
is it just 2, or can you do?
Oh, you can do as many as you want. Yeah, we could do this whole building. Okay? Again, there's some limitations beyond just the simplified version that we're talking, but that's the goal of it. It's to allow related networks that would normally be separated by a domain to communicate. And then there's one more. Unspecified. And I have no idea what an unspecified IPv6 address is. I don't know what it does. I don't know what it is. But you want to just make sure you at least know the 6 different kind, and the ones that are important is the global, routable, link local. You got to know a lot about link local. It's important to know the loopbacks and the unique local. And I often see at least one question on the CCNA about, what is a way that an IPv6 and an IPv4 network can coexist? They'll give you multiple choice. Or it'll say this particular network is using embedded tunneling. What can you tell about this network? Well, you need to know, that means that they're running IPv4 and IPv6, right? So it's not going to be an easy question. It'll be convoluted. You have to be able to understand a couple of different things. Okay. Let me see. That was this one and this one. Okay, so let's just visit our address again, okay? Now this /64 represents what? /64, what is it representing?
Total bit.
The total of what kind of bits? Yeah. Total network bits, right? If you look up here, the global routing prefix is how many? Plus a subnet ID, 16. So that is 64. So whatever your global routing prefix and your subnet ID is, that's the /64, and the remaining bits are what kind of bits? Host bits. Now, is a /64 the only network you could have? No. What is the range that you could have?
0 to 128.
Exactly. You could have 0 to 128. It's very uncommon, okay, to have anything. Now, sometimes I do see like 72s. You might have an ISP that pushes out and uses this 5th hextet, okay, but what you need to know is just how to do subnetting within the first 64. And we're always going to subnet to the /64, and we're going to do some examples of that later today, okay? So you can do anything from 0 to 128. 64 is the most common, okay? Okay, what are the different ways that a device can get an IPv6 address? There's 4 different ways. Let's see, what are the 4 different ways? Slack. And what is Slack? Not exactly. It's not DHCP. It's automatic assignment of IPv6 addresses, but it's not DHCP. What makes it significant? It does. It uses the EUI64 process, which I'll come back to. Okay. All right. So we've established that it's automatic, right? It does automatic address assignment. And I've also said it actually doesn't use a DHCP server. So what device does the assignment? Yes. Yes, the router does. And okay, so let's put here. So it's router. I'm going to do router based. It's router based. Okay, it's router based. And how does the router do that? Yes, not exactly solicitations. What does the router use? It responds to a solicitation. The router actually sends what kind of a message? An advertisement. Okay, so it uses router advertisements to respond to a router solicitation. Okay, so let's just go through it. Computer comes on, and it's like, I need an IPv6 address, so it sends a router solicitation. Okay, the router is using Slack, and so it will respond with a router advertisement. Okay, it'll respond with a router advertisement. And let's go back to what Daniel said, that Slack uses the EUI64 process. So basically inside the router advertisement tells the computer, hey, make your own IPv6 address. So that's why I say it's router based. The router doesn't actually give out an IPv6 address. What it does is it tells the end device what the network is, and then it says make your own. So it's both. The router does a little bit of the work, and then the end device does a little bit of work. Okay? And that's Slack. Auto configuration. Okay? It's auto configuration. All right, so I want you to do, on your command prompt, do an ipconfig all this time. Now I know this is super small, so look at your own screen where your ipconfig is. And if you look right here, I want you to look for the words auto configuration enabled. Does everybody see where it says auto configuration enabled? And then it says yes? That's Slack. Okay, that's Slack. So we can tell that Slack is working on our network for IPv6. Okay, that's Slack. We can also see for IPv4, you can look right above the auto configuration and see DHCP enabled, and it says yes. Okay, so if you look at yours, does everybody see that? Okay, good. All right, so what do we need to know? Slack, it does auto configuration, it's router based. It uses router advertisements to send messages to the host when the host requests an address with a router solicitation. Okay, and the process that the host used is called the EUI64 process, okay, which we'll dig into more in 150.
Is that default or is that state message default?
Slack is default. Slack is default because it's the easiest and it uses the least amount of resources. If you're with a Cisco device, the minute you do IPv6 unicast routing, Slack gets into effect. Slack gets enabled. Okay? All right, what's the second way? I heard you say it, Matt. Stateless DHCP. Now what that means is that we're using Slack and a DHCP server. Okay. What's the third way? Stateful DHCP. And that means you're just straight up using regular DHCP, but for IPv6. Okay. Now, all the time, the routers are always sending router advertisements. Okay. They're always sending router advertisements. And then there's one more way. What's the last way? Static, right? Just statically assigning, manually assigning them. Okay. No matter how your end device gets its address, what does it have to do once it gets it? It's got to do one more protocol. And what is DAD? Duplicate address detection. It wants to make sure that there's no duplicates. It does DAD. It does DAD. Okay. So let me go back to see if I got this. Okay. We're close here. All right. So everyone understand what a router advertisement is? That's the way that routers share messages. A router solicitation is when the device is requesting information. Okay. So if a router is communicating with all of the devices on the network, first of all, how is it going to be doing that? Is it going to use a unicast, a multicast, or a broadcast? Multicast, right? Well, there's no such thing as broadcast. And if it wants to communicate with all of them, it has to use a multicast. Okay. What is the all nodes multicast address? And what that means is, again, all of the end devices are getting communicated with using this multicast address. And whoever asked this question, don't answer it. Is that your question, Gabby? Okay. Yes, Daniel, FF02::1. Multicast addresses start with FF. Okay, multicast addresses start with FF. What do they start with in IPv4? What does a multicast address start with in IPv4? In IPv4, did you say it? No. That's the loopback address. So loopback address is 127.0.0 and then 1 or 27, whatever you want it to be. That's the loopback. Let me see if I can see. So there's the loopback, 127. I'm just going to see if I see any. NS lookup, maybe? No, that's not going to be. Exit. I got to think about how we can see it. What is it? Multicast for IPv4? 224. Starts with a 224. Okay, we have the all nodes multicast. That means I'm trying to send it out to all the computers. Then we need an all routers multicast. What is the all routers multicast? FF02::2. Those two addresses you need to know, and you need to know what they mean, right? All nodes going out to all the end devices. All routers going out to all the routers. Okay, so we got that. And that. We did that one. Okay. So let's see. What is the three methods for? All right. So Joey, just on your question, that you had the one about the router advertisement, right? So what are the 3 methods for an RA message? And actually, it's, I think a better way to say this is these use RA messages. They use RA messages, okay? Now, what houses the RA message? Like, how does it actually go out? ICMP v6. Okay, so you know how we use pings, right? We use ICM, that's what an ICMP is. That is how the router advertisement is carried. And again, that's at layer 3. Remember, we're still talking about the network layer. IP, ICMP, all of this is happening, router advertisements, this is all happening at the network layer. Okay, so I got that one. We talked about the EUI 64 process. Okay, let's revisit the router. Okay, let's revisit the router. What is the command to look at the routes for IPv6? That will show me IPv4 routes, right? Show IP route is for IPv4. Show IPv6 route for IPv6. Okay, what are the different codes that I would expect to see in there? C, okay, I would expect to see a C. And Daniel, what is the C? Connected what? You're on the right track. No. Yes, yes, yes. It's the directly connected network. Connected network. It's really important you include that last piece in there, the directly connected network. Okay, and then what is the L? Local what? Local connection what? No, that's the C. The IPv6 interface, right? The IPv6 interface what, Gabby? Yes. It would be the interface address. It would be the interface address. Okay? Now, the link local address, the FE80, what can I also use that for when it's on the interface of a router? So right here, if I have an FE80 address, what could I use that as? Yeah, it could be used as a default gateway. Here's another difference between IPv4 and IPv6. If we go back to what Matt said, is every IPv6 enabled device generates its own link local address. Okay? That is true about an interface on a router. It's going to get an IPv6 address, but it will also self-generate its own link local address. Because it's locally routable only, it could be used as the default gateway address for your IPv6 devices. Okay? We got that. Okay, did I ask everyone's question? In some roundabout way? I think so. All right, questions? So we're all going to do really good on the Kahoots that we're going to do when we come back from break?
Break? We're breaking.
Yeah, we're overdue for a break.
Oh, I thought you meant like we had a day off. Oh, I got excited.
There's only 4 weeks left. There's no breaks. Okay, it's 7:20. Be back at 7:28.
It's been all gas.
It is. There's a lot to learn. Yeah, I'm going to give these back and then go ahead and turn them in. Borgil, did you have note cards? Yeah.
There's another one missing.
Just set them on my desk there. I like your haircut, Marcus.
Is that lab actually due today or?
No. Lab 1292?
No, 1266.
1266?
Yeah, you have a configure IPv6 address and packet tracer due today. No, it's not normally what we do, so as far as
I will take a look. Oh, no, that should be April 3rd. Oh, I think because sometimes if I have time, I do it in class. We don't have time though. Well, we'll see where we're at the end of the day. Probably won't have time. Okay. Oh. All right, how many bits is an IPv6 address? 128 bits, right? How many hextets? 8. And because they are so long, what do we do with them? Yeah, we compress them, right? We figure out how to compress them. And we compress them just so that they're a little bit shorter, right? So what are the rules of compression? It has to be, yeah, you can delete the leading zeros, right? That's one of the rules, is you can delete the leading zeros. And then what is the other one? And what does the double colon mean, Gabby? If you have consecutive rows of zeros, you can use double colons. Is that what you said? Okay. It's hard for me to hear you. You can barely hear it, right? We're all friends in here now. Okay, so we're going to do a couple of assignments. And let's see. Let me just get them going here. Okay, so the first one we're going to do is this one, okay? We're going to compress IPv6 addresses by omitting leading zeros. Okay, now we're only omitting the leading zeros, so we're not going to do the double colons at this point. We're going to just practice one compression technique at a time, all right? This is not published yet. I'll publish it after we do a couple of examples. Okay, because I want to show you kind of an easy way to maybe think about doing these. Okay, omit leading zeros, do not use double colons. All we're doing is practicing omitting leading zeros. Do I do anything here? I don't do anything there, right? What about the second hextet? What would I do? What? I would make it so that there's only one, so I would omit the 3 leading zeros, right? How about 00F0? Right, we would omit, and 0030, right? We would omit this one. Okay, do not use double colons for this exercise. This is why we're doing an example. Okay, how about here? How about here? C0, and here? 0. Okay. Now, I will say I personally like omitting the leading zeros and not always using the double colons just because it's really easy to see. How many hextets do I need to have? 8, right? So if I leave the 0 in there, it just makes it easy to count the hextets. We're going to practice both. Okay, so here's the way I like to do this assignment so that I have a less likelihood of making a mistake. I like to copy the address, okay? Now, I look at it first. I look at it. Everybody hear that? I look at it first. Kind of get a game plan, and then I copy and paste it, and then I just start here, and I do the deletions, right? That way I have less chance of doing an error. Okay? And then same thing here, right? I'm going to look at this one. So what about right here, 2001? Anything? 9100, 4300. Yes or no? No. 6000. No. How about this one? Yes. B00. 0006. 7000. Okay, so I would grab this after I've looked at it and just kind of, gauge what I got to do, and then I'd go delete the leading zeros. Okay, everybody got a plan? Okay, I'm going to publish this. Let me see. Okay, so that's published. Go ahead and go do that one. Now, if you miss some, after class, ask me and I'll reopen them. Okay. Okay, so the next one that we're going to do is we're going to do the double colons, okay? So the next one we're going to practice is the double colons. Let me find it. Okay, now notice that this one says do not suppress leading zeros. Okay, so we're not going to suppress any of the leading zeros because we're only looking for groups of zeros in the hextets. And we'll use double colons. Okay, so again, this is testing for a different thing. This isn't testing our ability to find leading zeros. This is testing our ability to do double colons. Okay? And there's a couple of things to consider when you have double colons. First of all, what are some of the rules for double colons? Yeah, you can only use it once, right? So if you have groups of zeros, let's see if I can find one. Yeah, like here's a good example of one. Like if we look at this one right here, I have a hextet of zeros right there, and I have a hextet of zeros right there. I can only use double colons one time. I can't use it twice. Now, it doesn't matter where you use it. You can only use it once, okay? So in this scenario, remember, we're not getting rid of leading zeros. You're just leaving them alone. We're only addressing double colons. So which group of zeros do we want to do, the first or the second one? Okay, thank you. So I'm going to take this. I'm just going to copy it. I'm going to paste it in there. And then let's see. So I'm not going to do this group, right? I'm just going to go past it. And I'm going to go ahead and I'm going to get rid of this group. And I'm going to have that in there, okay? Now, how many hextets do we need? We need 8. Right? So you can always count up your number of hextets to know how many groups of zeros you have in there. So here's my 1, 2, 3, 4, let's see, 5, 6. I have 7 hextets. So this double colon represents how many hextets? Just one, right? Let me see if I can find some that have multiples. Of course I can't. Let's see. What if this A was also a 0? Like, let's just say that this was a 0, right? Then I would do exactly. And this FC, what kind of address is this? What's the FC? Unique local. Good job, Matt. Okay. So I can see that there's 6 sextets, so I know that I would need to add 2 sets of zeros. Okay? Now, what if this was a 0? Right? And so I had a choice of doing this group or this group. Which one is the better one to do? Exactly. Do whichever one is the longest string as the double colons. Okay, so you might get a question like that on your brain teaser. So you can do either one, but usually you would do the longest string. Okay? Now remember, we are not getting rid of leading zeros. Even though that's the better way to do it, right? Where you would do that, we're only doing double colons. Okay, so I'm going to publish this one. Okay, go ahead and do that one. If you have a question about how to do one, just call me over and I'll look at it. Do the copy and paste thing, you're less likely to make a mistake. Yeah. Let's see. Which one are you looking at? Yeah, so see this one right here, whenever you've got a full hex set of zeros, you can use the double colon. So like right here, you could replace this with double colons. So like if you just take those zeros out of there, see how it automatically makes them 2? Yeah. And then let's see, you wouldn't do anything else. And let's see, how about this one up here? Yep, that one right there. So now look at this one. So see, you have this here and you have this here. So it doesn't matter which set you do. Let's do the long set. So go to the end. Yeah, that's perfect. Yeah. Yeah. Okay. And again, here it doesn't matter. You could either do this one or this one. Okay. How'd it go? Okay. Now we're going to do full compression. So we're adding it all together. Okay, we're doing full compression. So you're going to make this address as small as possible. You're going to omit the leading zeros, and you're also going to use the double colons. Right, so let's take a look at this one. 2001, anything here? Anything here? Anything here? What about these? Right, I'm going to change, oh, look, there's 3 of them. So I'm going to get rid of these, and I'm going to do double colon. What about this one? What about this one? I'm going to get rid of the leading zeros. I'm going to make it as small as possible. Okay, how about this one? Everyone? No or yes? What do I do? Double colon. Okay? Make it as small as possible. Okay, I published it. Joey, can I have your flashcards? Thanks. Okay, that's fine. That's right. Okay. Looks good. All right, now the next one we're going to do is we're going to decompress everything. We're going to put it back to the full address, right? That's why we have to know how to look at these, right? Double colons. 1, 2, 3, 4, 5, 6. I have 6 hextets. So how many hextets of zeros do I have? 2. Okay. What about right here? 2001 BAD. You got to get a 0 in there, right? So with these, you're decompressing it. You're putting it back to its full IPv6 address, okay? Okay, it's published. Okay. And we're going to do one more. Okay. Now this one is we want to identify the subnet ID within the IPv6 address. Okay. This is kind of in preparation of getting ready to do a subnetting problem, okay? And we know that there's how many hextets in an IPv6 address? 8. And which hextet is the subnet ID? The fourth. Okay, now once in a while, that could be different, right? When you get out in the real world, it might be different, but for all educational purposes, that's the way we teach it, okay? Now the ISP might give you like a /56 or a /60, which we'll talk about, but we ultimately still want to get to a 64. We always want to get to a 64. All right, so for this, it's asking us which one of these hextets is the subnet ID. So what would the answer be here? BC, yeah, BC93. Okay, given the IPv6 address, which one of these is the subnet ID? B834. Literally, you're just looking at the address and telling me which one would be the subnet ID. I just want to make sure you can identify the subnet ID. Okay, so I'm going to publish this. Yes.
I have a question about my understanding of this.
Yeah.
So let's say this was, would it ever be a /70?
It might be.
Okay, so if it is, I'll just count up to the 70th bit, and then that's where I stop. Like, let's say, 70. Oh, all right. Let's just say it stops at the 24 bit. Do I just do 24 as the answer? Or?
Yep. Yep. And actually, we're going to do an example of something similar to that. Okay, something similar to that today, and that might explain some of that. So it could be a 70. It's not that common, but it could be. Yep.
All right, so it'll be, so this one is 64. It includes the whole text.
Yeah.
So at 70, let's say the cutoff point is A. It'll be the first three.
So let's see. If we did if we did 70, right? So we would be 48, 64, and then this would be 68, and then we'd have to bid out the 4 to get to the 70th bit.
Okay.
Right? And so the network would actually be 2001, 6576 BPCA 492C 2 4. And then all of these would be host bits.
Okay, so like the answer would be, if it was a multiple choice, it would be 24, right?
It would probably be 24.
Okay.
Yep.
All right.
Yeah.
That's-
Yep. Yeah. Good thinking about that. Okay. Are we all done with that one? Okay. Let's pull this all together. All right. We're going to kind of review everything. Yep. Everything in the module. There's more than one. Okay, so if we're using SLAC or stateless DHCP, that means that the router is telling the host to make its own address. The host will make its own address using the EUI64 process, or it will randomly generate an address. So if the EUI64 process is being used, what are we doing to get that address? What is the host doing? How does it make it up using the EUI64 process? It uses the MAC address, right? The host device is like, well, I know what my MAC address is, so I'll just go ahead and take this address. I'll add some bits to it. Do you know what bits it adds? FFFE. It's going to add the FFFE in the middle because it has to get to 64 bits, okay? Now, if it doesn't use the EUI64 process, it'll just randomly generate an address. Okay, why wouldn't I use the EUI64 process? What would be the reason for not using it? Yeah, a security concern. So what's the security concern, Gabby? What can be reverse engineered? The MAC address. The MAC address can be reverse engineered, and then you could have some spoofing happening. Okay, so do our devices use EUI64 process? How could you tell? Yeah, what did you find on the IP config? Exactly, it doesn't have FFE in the middle. So go ahead and pull your command prompt up again. And do an IP config. Okay, do an IP config in the command prompt. Find your link local address. And if you notice here, you don't see any FFFE. Okay, that means that these have been randomly generated. Okay, the device just randomly generates it. And years ago, we had EUI64 process. And we had a new network administrator who turned it off. So I was like, oh, well, can you turn it on in the VMs? Because I want to be able to show that. And they left it on in the VMs for a while, but lately, now the last 2 semesters, they've been turning it off in the VMs too, so we can't even see it in the VMs. What? Remember, there's no broadcasting on IPv6. So every IPv6 enabled device needs a what? A link local address. A link local address. That's all that's needed. Remember how Matt pinged my link local address? Nicely done. Subnet ID field, we must borrow bits. Borrowing bits is for what? IPv4 and specifically VLSM. Yeah, VLSM. Last one. IPv6 unicast routing. Only one person got it right? Ouch. What?
So that's Gabby.
It probably was Gabby. Matt, not bad. Daniel. Gabby! Nicely done. Oh, look at that score relative to everyone else's.
100%.
I can tell who was watching some videos this weekend, right? Yeah, there's so much to cover in IPv6. All right. I have published that. Okay, now this is on the address types. Link local, unique local, loopback.
I already forgot the name of IPv6 routing, unicast routing.
What is it, Gabby? IPv6 unicast hyphen routing. Why? Do you think it's going to be on this Kahoot too?
No, I was just thinking about it. I don't care if it's a thing. Remember? I'd like to try and remember.
It's an important thing. I'll tell you, one time a whole network wasn't working. We're like, why isn't this network working? It was missing the IPv6 unicast routing, yeah. let's see, FF02, that's the all host or the all nodes, right? I would like everyone to get this right. Did somebody actually do the no shutdown? Do you add to a router for IPv6 routing to work? This is the one that was the last question of the previous Kahoot. You got it? Good. Unique local. So this is the unique local, FC through FD. Dad. Dad. Yeah, an FE80, it has to have a link local. Now, it doesn't have to have a global routable, right? A globally routable address. It wouldn't be able to get out on the internet, but it doesn't have to have one. Yep, that's a globally unique address. That one's routable on the internet. Good job. Routers will not forward these. So remember, this is a unique local, so it's only relevant to its local subnetwork. Nicely done. Yeah, that's that embedded where you can embed the IPv4 packet or the IPv6 packet in the other one so that it can move across the network. Oof. FF02::1. And I would accept the all nodes. I think somebody put all nodes, so that's right too. But this is specifically wanting the actual address. Daniel made it, Gabby, and Matt. Good job. Nicely done. So here is a look at the different link locals on our network, but then also look at this, FF02::1, what is it? It's a multicast for all, all hosts, FF02::2. All routers, and then here's some other multicast groups that it belongs to. Now this could be a variety of different things. It could be something that was manually set up by the network administrator. One of these is probably a DHCP. So there's a couple of different ones in here, but we can see there's all kinds, okay? And you see how they're set permanently? That means that somebody's manually set them, right? Or identified them as needed on our network. Okay, I'm gonna publish that Kahoot. Go ahead and enter that, and then let's take a quick break. It's 8:25, come back at 8:31.
Can you unlock that first one for me?
Yes. Let's see. I'll unlock it for anyone that needs it. You're welcome. Ozzy, I unlocked that first brain teaser. If you wanted to redo it again. You don't have to, but I unlocked it if you wanted to. Gabby, in my video for Slack and DHCP, did I do an example of the EUI 64 process? I did, okay, I just couldn't remember. And it's me doing it, right? Yeah. You're welcome. There you go. Lou, did I give you your cards back already? Oh, I did. Huh? I am. Okay, so I just want to review IPv6 subnetting, and then we'll do a couple examples, okay? The first thing I want you to think about with IPv6, and I might have said this already, is IPv6 subnetting is easy. I see that typically there's a tendency to want to make it complicated or overcomplicate it, and I think that's partly because in IPv4, doing VLSM and subnetting is kind of difficult. You got to figure out how to, increment, and you have to figure out the positional values and all that. And we're doing all of that in order to try to save addresses. In IPv6, we don't care about saving addresses. And so what we do here is the ISP will give us the first 3 hextets, okay? And then they'll say, hey, just use the 4th hextet and then subnet however you want. And the key is just you want it to make sense, right? Ideally, I see IPv6 networks all the time that don't make any sense. But if you can, make it make sense so that it's consecutive, or maybe it aligns with your building numbers or your room numbers or something like that, okay? Now, it is also, typically, you're going to go out to the 64th bit. But what the ISP gives us initially is the 48, right? So in this case, they're giving us 2001 0db8 AC AD : 48. That's what they give us, and then they'll say, hey, go ahead and use the 4th hextet to do your subnetting. They might give us 2001 0db8 ACAD : 1100:/56. Okay? They might give us a 56 and then say, like, use these to do your subnetting. We're still using the 4th hextet, but they're telling us, look, 56 of these bits are ours. Don't use those, right? And what does that work out? These are 16 bits here, 32, 48, and then remember, each one of these represents 4 bits. So that's the 52 and 56, because remember, this looks like this, 0001, 0001. So 16, 32, 48, 49, 50, 51, 52, 53, 54, 55, 56. Okay, but we're still typically going to be doing subnetting with whatever nibbles are left over, okay? Now, Lou earlier asked a question like, could they ever give us a 70? And they might, right? It's not as common, but they could. They could give us, let's see, if they give us a 70, what hextet would we be in? We would end up in the 5th hextet, and they might say, subnet in the 5th hextet. Okay, they could do that, right? So let's say if we did that. So 2001 0db8 ACAD. Actually, instead of 70, I'm going to do, just so the numbers are easier, I'm going to do 68. ACAD, 1111, and then let's do A000:68. Okay, so they could say, look, I'm going to give you a /68, and then you're going to subnet in the 5th hextet. That could happen, okay? Here, we just want to kind of learn how to use the 4th hextet, all right? Face that if it ever happens in the field, right? We're going to just learn how to use the 4th hextet, all right? And if you get good at the 4th hextet, you can do any of them. It doesn't matter. You're just looking at the network bits. You're just looking at the bits and listening to what the ISP tells us, okay? This is the network address, right? The first 48 bits. And then each network is going to get its own unique subnet ID, and that's what makes each network different. And what they're doing here is they're simply just counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, ABC, right? So each of these are networks, because remember, every local area network needs its own unique network address. That doesn't change with IPv6. And what makes them unique is the subnet ID. Okay, what makes them unique is the subnet ID. All right, so let's take a look at what this would look like. So there's our network. We started out with a 48, and then we did subnetting, and I'm just going to assign these. I'm going to assign each of these. So here, I'm going to assign this network, right, this LAN right here to the 0001. What address would I use on this interface? Yeah, or :1, it would actually be colon. And what is that? Which address is that? It's the first usable address. That's not different. In the IPv4 world, we use the first usable address. In the IPv6 world, we use the first usable address. Okay? Does it have to be the first usable address? No. As long as it comes from that network, it works, right? As long as it comes from the network, we usually use the first usable because that's easy to keep track of. And then also, what is this interface on the router that faces the LAN? It's the default gateway. Okay, it's the default gateway. Now, I'd give the next network, I'd assign it to the other LAN. Okay, again, they all still need their own unique network address. That doesn't change. Now, what about the WAN? The WAN needs its own unique network address. Okay, got this one, got this one, okay? So how many networks, how many LANs do I have up here? 4. How many WANs do I have? 1. How many default gateways would I have? 4, right? 1 on each LAN. None of that changes, okay? None of that changes. And we set the IPv6 addresses just like we do IPv4 with a little bit of a change. In IPv4, we write out the subnet mask. Well, here we use the / notation, okay? Now, when you look at these commands, there's 2 things missing. What's missing? No shutdown. Exactly. We have to add the no shutdown because that interface doesn't go up unless we activate it by using the no shutdown command. And then there's one other thing that we should have. The description. We want to have the description in there, okay? Again, the commands are pretty much the same with the exception that the IPv6 address is written differently, okay? All right, so we're going to do, I'm going to hand this out, and we're going to do the side that has a /52 first, okay? So we're going to do the side that has the /52 first. I think enough there for each of you. Okay, and let's do the first one together, okay? Let's do the first one together. Let me pull it up on the screen here. All right, so we're going to do this one first. Okay, so we're going to do this first. And let's just make up some LANs, okay? So we'll do like LAN 1, 2, 3, 4, and 5. So we're just making up some LANs, okay? And then let's actually add a WAN as well. So we're going to add a WAN down here at the bottom. Now, does the size of the network matter? It doesn't matter, right? It doesn't matter. I will tell you, if you're doing IPv4 and IPv6, I usually do them in the same order, right? And since IPv4s, we always have to do it by the biggest network to the smallest. Pretty much the IPv6 will go the same way, just so they match up, okay? All right, now if we're looking at this, What part of this is the network address? All the way to the, right, because of the 52. So all the way to the 1, right? All the way to the 1. And because this is a 52, what the ISP is telling us is you can't change this part, okay? However, go ahead and use the rest of the 4th hextet to do your subnetting. And then we're going to use the second nibble, just because we decided to, not for any other reason other than that I'm the network administrator and I can do whatever I want. All right? So for the network, it's the same all the way across. Okay? And then over here is where I have, and there's a couple of ways you can write this, right? You can even pull this over here, right? Because it's part of the subnet ID, it's just that it can't be changed. All right, so all the way down, I think A1, 2B, A1, 2B, right? This is the same all the way down. Well, do this one all the way down, and then the next one we'll do arrows. Okay, so that stays the same. And that kind of makes sense, right? This is all one company. You know, let's call it Safeway. Okay. The ISP said, hey, don't mess with my 50-second bits, right? Don't mess with that. But we're going to do a subnet now over here. So somebody just give me, if we're using the second nibble, what could I put in there? Just throw something out. 1. I just put a 1 in there. And then the rest I just zero out. Okay? Okay, what about the second network? 2. Right? So this is how simple it is. The thing that's important is just make sure you don't mess with the bits that the ISP tells you you can't mess with. Okay? And now it is a 64 because we're counting all of these. So we're going to count all of these bits. Now, if you, as the network administrator, wanted to call it a /56 and use those other bits later, you could do that. And if we have time, we'll do an example of that. But you know, you have a lot of flexibility, okay? You have a lot of flexibility. Yes? Yeah, you read from here over. So this is nibble 1, 2, 3, 4. Yep. Okay. Okay, so now we've got the network and the subnet part. The first usable address. What's the definition of the first usable address? As it relates to the host bits? All bits off except the last one. Okay, so the way this would look, it would be 2001 A12B 3333 1100. Now I'm going to write it out. I want you to write it out this first time. Okay? We're not going to suppress just because I want everyone to see it. 1, and then this would be a /64. Okay? So this is the whole address, 2001 A12B 3333 1100 00000000000001 /64. That's the first usable address. Okay? We'll compress it on the next one. I want to show it both ways. I want to make sure everyone understands. Okay, now, what's the last usable address in the IPv6 world? All Fs. Okay, so this would be, how many hextets of Fs? How many? 4 hextets of Fs. 1/64. Okay. Now for the second network, let's compress our zeros, right? Okay, so I can compress these, right? And I'm going to compress the leading zeros for this one, and then we'll do double colons for the next one, just so we can see it in all the different ways. Okay. So the first usable address would be 2001 A12B 3333 1200 0:0:0:1/64. Okay, so that's another way to write it. Now there is no way to compress any other number, any other letter. So there's no way to compress FFFFF. Okay. All right, now for the third network, let's do all the compression. All the compression would be colon, 1/64. 1/64. And for the F's, just to make your life simple, you can just draw an arrow so that I know that you know that those F's would be the same. Okay? All right, so I want you to go ahead and finish this one. And then over here, let's do land A, B, C, and D for the second one. Okay, so finish the first one and then do the second one. And if you have any questions, call me over. Yes. I did. Did you compile the totals somewhere in there? Yeah, like like all the yeses, there's 27 yeses, or is it just the list?
It's the list and it has everything on it that.
Okay.
So it'll have the responses, like the definitely, the maybe nots. all
Okay.
those in there. You can
Okay.
If you don't use Excel, I think I remember vaguely how to use Excel to get the lists and stuff.
I might be able to. Okay. Worst case, I'll do it manually. Or I'll wait until you come back on Thursday and I'll have you do it. But I'll probably have time to do it.
I'll figure it out. It's been
I know,
year.
me too. Yeah, but I did get it.
And it's a 205 patent lattice survey as well, but obviously I can't access it.
Oh, okay, I'll go in and look at it.
Yeah.
Okay, and then I added you to the other two. Did you see
Yes.
that? Okay, cool. Thank you, Sam. Crap. Need help? Do you have all three of them done? Excellent. When you're done, flip it over and do the next side. Okay. Before you go, I want to check the first side that you did. Let me check your first side, Marcus. Oh, yeah, do all those. Okay. Perfect. Let's see. Do me a favor and draw a line down there so I know that you know.
I was getting there.
Let's see, and that one looks good, and that looks good. Perfect. Using the fourth nibble. Nicely done, nicely done. Okay, and then do the other side. Yeah, you can draw, you can use the line, you know, you can draw a line, as long as I can tell that you know what you're doing. Nicely done. Do the other side. Overachiever. I like it. Oh,
I'm tired.
yeah. Fourth, third, second. So give me a second. I'm going to publish that so that you can mark it. Yep, I'm gonna have you mark it, so give me just a second. I'll be right there, Lou. Okay, so before you go, I want to show you two things. Okay, so right here, this is what we're working on right now. Okay, so before you leave, please let me check the 3 that we did on the front. Okay, and once you're done with that, you can go in here and mark that you turned it in, right? Just send me just say, you know, we did it in class and that I checked it. Okay, so let me check it. And then the next thing that I just handed out was a topology for the lab that we are doing on Thursday. Okay, read, oh, it's hard to say. Read the lab before you come to class, okay? I want you to read it all the way through because I want the lab to go smoothly. The other thing that you're going to do is you're going to add the addressing to the to your topology. Okay, so you're going to add the network address. You're going to add the switch's VLAN address. You're going to add the interface. You're going to just write it in and bring this with you. Yeah, yeah. This is 1292's topology. Okay, bring this with you. And the same thing here. There's some questions in here. Did you read the lab? Did you finish filling out the topology? Okay? And then it's suggesting you might want to work on your descriptions so that you already have those ready and you can just copy and paste them into the lab, okay? Any questions on those two things? All right. Yeah.
Since the /48 is in the fourth test tech, I'm going to mess with the third nibble in the fourth
That's
tech.
perfect. Yep. So that one stays the same. And this is just like a traditional. They give you 48 bits and you use the fourth hextet, just like that. Perfect. Okay, mark this. Okay. So you can take that one home and finish that. Okay. Let's see. Yes.
A few assignments that didn't have squares and I was going to ask you about.
Let me check these guys first, and then I'll come right back. Are those in-class activities or out of class?
Yeah, I don't really want to read all of them.
Oh, okay. Gotcha. That looks good. Okay, so this one. So notice here, this one says to use the third nibble, and you're using the first nibble. Okay?
Can you check my? I don't think I did this part quite correctly. Like, I was kind of confused by that.
Yeah, you did. So
Okay.
let's see, 48 bits. So it's telling us this has to stay the same. So you bring that down. That, you don't really need that there
Okay.
because that's here, right? And then that looks good. Now, this one is a 56. And so it's keeping both of these. See, this is 48. This first nibble is 52. The second nibble takes us to 56. So you have to keep all 56 bits. So that means this is 1, 1, 1, 1, 1, 1, 1, 1. Just like this one was 52, now this one's 56. There we go. Yeah. And that one's the fourth, and that one, yeah. Okay, so you can mark that we did it in class and that I checked it, and then do this one at home. Okay. Gabby, is yours all done? Okay, I'll be right there. Third nibble. Yep. Okay, so you can mark this one that it was checked and then do that at home. I'll be right back, Marcus. Did you get both sides done? That looks good. That looks good. So same thing, go ahead and mark that we did it. Let's take a look. Yep. Yeah, that's exactly right. So 1, 1, that looks good, and then that you're carrying down. So just so you know, right, these are those,
Yeah.
right?
Yeah. So this is 3 here, then the 4th one. and
Right.
the 4th.
Yeah, it's not wrong to do that. I just want to make sure you know that you're not like 1, 1, and then another 1, 1.
I was thinking wrong. Like, wait.
Yeah.
Extra one.
Yeah, these look good. Okay, so mark that we did this in class, and I checked it, and do that one at home. Ozzy, are you done? Did I already look at yours? Oh, I already looked at yours. Okay.
Okay, so. And then, which one of those on the back we did for this one? Or am I just like?
So this is, I want you to read the lab. That's the
Okay.
lab, and then you're going to fill out the topology and
Okay.
bring it to class on Thursday to do the lab with.
Okay, I get it now.
Yeah. Okay, so mark that we did it and do the other side at home and bring it back. Bye, Guillermo. See you Thursday? Okay. Okay. Okay, good.